Here's another problem. Last one for chapter 8.2. 8.2 is on GCF factoring. 8.2, GCF factoring. Very important element of this whole factoring process, which is possibly the most important thing you learn in high school math. It's certainly one that you won't see the end of it in Algebra 1. It says find the area of the shaded region, so these corners basically, in terms of x in factored form. The diagram shows a circle with a radius x inscribed. That means it fits perfectly inside. It touches at all these 4 points in a square, inscribed in a square. Okay, so try to do this problem on your own and pause the video and come back to it and see what I do with it. So I'm going to think of this as two shapes, a square, and then we have to subtract this circle. So the square has side lengths of 2x and 2x. So the area of that square is 4x squared. And the circle has a radius of x. So pi r squared is the area of the circle. So r is x. So in this case, the area of the circle is pi x squared. So we're going to subtract these two things. Now, they're like terms. So you might think of it that way, that this is 4 minus pi x squared. You can think of it as that, 4 minus pi x squared. If you were thinking about factoring these two things, you would take the x squared out. So you would take the x squared out by removing it out of both of these things. Typically, we write that in front. And then x squared times 4 is 4x squared. And minus sign I'm going to leave there, and x squared times pi is pi x squared. So either way you look at these are exactly the same because we have the commutative property. We're multiplying this times this, and here we're multiplying this expression times this. So this expression is a binomial by a monomial. This is a binomial by a monomial, and we can commute because we have multiplication. So both of those are exactly the same. I would expect this is the normal way to write this if we're asked this particular problem to write it in terms of factored form.